All right, welcome back. In this video, we are going to talk about groups. All right, and in abstract, what you have to understand is that abstract is basically the study of symbols and how you can manipulate them. Okay, so once we are coming to talk about groups, what you have to know is that formally, groups or a group is a set, right? A set, say J, a set J, okay, equipped with a binary operation. Usually, we denote this binary operation as star. Okay, so this group must satisfy certain properties, four properties formally. Okay, we have closure, we have associativity, and we have identity element, and finally we have the inverse element. Okay, so every group must satisfy those four axioms or properties for it to be called a group, or for it to be qualified to become a group. Okay, so these are the properties right here. That is the closure, the identity, the associativity, and the inverse element. Okay, so with the closure, if you pick any two elements, here, let's say an element A and element B, okay, they should all belong to G, right? They should all belong to G, which is the group. Okay, right? Now, if you operate or you perform the operation on them, which is the star or any operation at all, they should be under the group. Okay. Now, when it comes to associativity, when you pick any three elements, A, B, and C, right? A, B, and C, they should belong to J. Okay, right? So when you have A, when you perform the operations on them, A star B star C, you should be equal to, right? This operation should be equal to this. Okay, so that is what we call the associativity property. And the identity element, okay, when you pick any element, right, identity element is usually denoted as E, okay? So when you pick an identity element, which is the E, right, then you perform an operation on it together with an element called A, right? It should be the same as when you pick an element, which is A, okay, perform an operation on it called the identity element. It should give you the element back. That is what we call the identity element. Okay, so when you talk about the inverse also, the inverse is when for every element, okay, for every element, A must belong to J. Okay, so an element A, that is A inverse, okay, should belong to J. Okay, such that when you take A star A inverse, it should be equal to A inverse star A, right? And that information should be equal to your identity element, right? So the identity element to clear the concept of a group. Okay, so we know that for this particular problem, Z under the operation multiplication to be a group, then it must satisfy these four axioms or properties. First, we have the closure. Two, we have the identity. Three, we have the inverse and the associativity as well. Right. So first, what we have to think of is we have been given Z, which is integer, under the operation multiplication. So once we have these informations, these symbols, we already know that abstract is the study of symbols and how you can manipulate them, right? Good. So here we have this symbol, which is Z. What do you know about Z? Integers, right? So you know that integer is a whole number that can be either positive, negative, or zero. We don't accept a fraction or decimals in integers. Okay, so this is how you define integers, right? Positive, negative, or zero whole numbers. Okay, so we start from the negative. Okay, so from negative infinity, whole numbers, right? So negative 1 here, 0, 1, da, 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 to infinity, right? So any number that is a whole number, either positive, either negative, or zero. You know, zero is neither positive or negative. The zero, we are not considering either positive or negative. What we are interested in is zero. Okay, so once we know the definition for integers, then we can go on and answer this particular problem. Okay, so integers under this operation multiplication. Okay, so let's check the properties for a group. Okay, so first property is closure. Okay, so for it to satisfy the closure property, we know that um, the product of any two integers, right, must be an integer, right? So when you pick the product of any two integers, let's say you are picking, let's say A and B belongs to J, okay? And you are picking A to be, let's say, -1, right? And B to be, let's say, +1. Okay, these two numbers, when you multiply them, they are still coming from the integer set or the set of integers. So let's say a dot b is equal to -1 times 1, and that's equal to -1. And -1 is part of the integers. Okay, -1 is part of the integers, the set of integers, right? So the closure property is satisfied. So let's check for associativity. All right, so associativity, we have to pick any three elements, right? So that when you perform the operation on them, your right hand side should be equal to your left hand side. Okay, so when you pick any three elements, let's say A, B, and C, okay, A, B, and C, that belongs to J, right? This element, when you operate the operation, the multiplication operation on it, you should have the element in this set. All right, so let's say A star B star C, right, should be equal to A star B star C. All right, this property is also holding, right? So this property is also true. All right, let's check for the third property, which is the identity element. So we have the identity element, the identity element. So with regards to the identity element, when you have an element, let's say an element called A, right? When you operate the operation on it, or when you perform the operation on it with the identity element, you should have the element back, right? So for instance, you have A star E, it should be the same as, A star E should be the same as E star A, okay? And this information should produce the element back. That is what we mean by the identity element. All right, so with the identity element, you know that the multiplicative identity, right, in integers is always 1. It's always 1. So when you take 1 times A, it should be equal to A times 1. All right? When you take 1 times A, right, it should be equal to A times 1. And that is equal to A. So the multiplicative identity in integers is 1. Okay? So that is the identity element E is 1. Okay, so the identity element, that's the identity element E is 1. Okay, so once this property also is true, or this property has been able to satisfy, we check for the last property, which is the inverse. Okay, so let's check for the inverse element, the inverse element. Okay, so that is the interesting aspect. Okay, so with the inverse, for every element, right, that you pick, okay, it should come from the Z. Okay, the integers, the set of integers. So for instance, when you say that for every element, say A, that belongs to Z, okay, this information you are having right here means that there must be an element B that is also in Z, right? So there must be an element called B that is also in Z. So there must be an element, there must be an element called B that is also in Z, in a sense that, or such that, A dot B is equal to B dot A, and that should be equal to 1. So such that A dot B should be equal to B dot A, and that should be giving you a number called 1. Okay, so with the inverse, when you have any element called A, it should come from the integers or the set of integers. And another element called B should come from the set of integers. When you multiply these two elements, they should produce a result called 1, a result of 1. So either side you do it, A dot B should be equal to B dot A, and that should give you 1. So when you go to the set of integers, when you pick any two elements and you multiply them, it should give you 1. Okay, so let's test for 1. Okay, so 1, we are taking A to be 1 and B2 to be 1. Okay, so 1 times 1 is equal to 1. Okay, let's pick negative 1. Negative 1 times negative 1. Okay, that is also equal to positive 1. Okay, so we realize that negative 1 and positive 1, when you combine positive 1 and positive 1, multiply them, you get positive 1. When you take negative 1 and you multiply them, you get positive 1. So, but when you go ahead and take other elements, for instance, when you take A to be 2 and you go and pick B to be, let's say, 3, you will not have your result to be 1. Okay, so we can see that the only integer that have an integer multiplicative inverse are 1 and negative 1. All other integers will not satisfy. So we will conclude that we can say with confidence that the inverse element destroyed the properties. So it makes this information over here not to be a group. So the inverse doesn't satisfy the property of the group for this particular question. So inverse fails. Inverse element fails. Or because when you pick any other integer and you multiply them, you are not going to have one apart from -1 and +1. All right, so we can conclude that since the inverse element does not satisfy the four axioms or does not satisfy the properties of a group, we can conclude that z under multiplication or integers under multiplication is not a group. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.